And a pair of aces. You have a kind bitch. That's not. Oh, fuck. Randy, come on, man. Sorry about that. I'll grab towels. Oh, Blandy, you gotta hear Andy's joke, man. It'll be funnier the second time. Oh, yeah. I was just saying, when the cup was on the table, it was in a state of equilibrium with the force of gravity acting downward on it and the normal force of the table acting upward on it. When it got knocked off, the unequal forces that caused it to accelerate downward. So a force causes acceleration? Yeah, objects are drawn together by gravity, causing them to accelerate towards each other. Yo, dogs, I found a graph of it. Huh? So half the mass of the cup is 495 grams. The distance is 0.8 meters, and it's obviously the initial velocity is 0. So I calculated the time to be 0.28 seconds till it hit the ground, and its final velocity right before hitting the ground was 3.96. I also got the kinetic energy right before hitting the ground over here. It's going to be 3,880.8 newtons. And over here we're going to have the potential energy, which is going to be the exact same as the kinetic energy right before hitting the ground, as the law of the conservation of energy dictates that those would be the same. So obviously that's how it would be. Yeah. Even something as simple as placing a card down on the table creates a small amount of force. That force causes the table to vibrate, which causes a wave to move throughout the air, y'all. Yeah, man, physics is pretty cool. I really wouldn't be talking about anything else right now. Hey, did y'all know that the sunlight streaming through the window gets trapped inside, causing the room to heat up? How does that happen? Yeah, the sunlight enters as shortwave radiation, but when it hits the walls or the furniture or anything like that, it becomes longwave radiation and it can't escape. That's interesting, man. I got one. When we eat snacks, our bodies convert the chemical energy into body we can use, like for metabolism and stuff. Blandy, this is boring. Hold on. That generates heat as a byproduct, which increases the order of entropy, like the second law of thermodynamics, man. You know, it's like that energy it will never be as usable, and then it's kind of cool. Sorry, Blandy, I was wrong on that one. Never mind, man. My bad. Yo, Blandy, you should use that with the ladies, bro. Do you know why waves are louder than other waves? Oh yeah, I know that one. Sound creates vibrations in the air molecules around it. Those vibrations move outwards, forming compression waves. I'm essentially shaking apart your body right now without your consent. Anyway. Higher amplitude sound waves create greater pressure in the air molecules around it, forming the greater perception of sound. Guys, can I borrow a charger? My phone's dead. Oh yeah, I got one. Oh shit, oh thank you, man. Thanks. Oh, do you boys want to know how the phone charger works? I got you. So think of it like a water pump, except with water. You know, instead of water, you got electrons in there. When you increase the pressure in your water pump, your water starts to move. Same with your electrons. You know, they start bumping into each other, causing the other electrons to bump into each other. It's kind of like a chain effect, and then it goes throughout the wire, pushing that energy all the way throughout. So it's kind of cool. I actually got a diagram right here if you boys want to see it. I always find them just sitting around here. So like I was saying, think of electric current like the flow of water. Instead of H2O molecules, it's the electric charge that's moving. In the metal wire circuits, it's electrons that make up the flow of the charge. You see, when you plug in your phone, it's not the electrons traveling from the outlet to the lamp, it's the energy. The electrons in the lamp filament already exist there. Power companies aren't selling you the electrons, they're selling you energy. You're the ones applying the electrons. Think of it like a water pump. You supply the water, they supply the pressure needed to eject it. To understand electricity, you need to understand alternating and direct current. Direct current flows in one direction, like when you're using a battery. Think of it like a straight line. The positive terminal is always positive, and the negative terminal is always negative. Now AC does what the name says, it alternates. In an AC current, electrons wiggle back and forth, changing directions. The back and forth happens because the voltage at the source, like a generator, switches polarity. Most of the power in our homes runs on AC, but stuff like laptops often use DC, which is why they need batteries. However, you can power them with AC using converters. In North America, the power outlets give you electricity that switches back and forth really quickly at 120 volts. Your mobile phone, on the other hand, uses a steady 5 volts of DC. Now if you look at my chart right here, most mobile phones, like I was saying, is 5 volts of DC. And they usually consume 5 to 20 watts of power. Looking at that, we get 1 to 4 amps of electric current, and that gives us 120 or 30 ohms of resistance in the phone. You guys, how many more hens are we doing? I got $30 in my bank account, and my car payment's tomorrow. Kind of a gambling addict. Classic Blandy.